Hi class, this is the recording for the practice test answer key. And so I already have the correct answers bolded, but I'm going to walk through how I got there. So I'm going to pull in this handy dandy periodic table. So for the first question, we are looking at which element is in group 2 and period 7. So you have to remember groups are columns, so we are in this group here. This is group 2. And then period 7 would be 1, 2, 3, 4, 5, 6, 7, all the way at the bottom. So we are looking at radium. And then for 2, which list includes elements with the most similar chemical properties? So chemical properties trend for groups as well. So this was something, a nugget of knowledge that you guys should know is, okay, I'm looking for 3 elements in a group. And so if we look at where bromine and gallium, here we go, and mercury, there's no really trend there, so their properties are probably not going to be similar. This is the same process for B. And then the reason why it's not nitrogen, oxygen, and fluorine, because that's across the period, and chemical properties trend down the group, which leaves us with oxygen, sulfur, selenium, which would be, let me erase here, these guys. So recognizing they're down a group, therefore have similar chemical properties. Okay, and then the periodic table, you should know that it's arranged according to increasing atomic number. And which list of elements consists of a metal, metalloid, and nonmetal? So this has to do with recognizing where the metals, metalloids, and nonmetals are on the periodic table. So on this table I have pulled up all the metalloids are in bright yellow over here. And then everything to the right is a nonmetal, everything to the left is a metal. And so the only 3 that have it is C here, because we have a metal, a metalloid, and a nonmetal. Then 5, the element in period 2 with the largest atomic radius. So we are looking at this guy here. Now if I was asking this question, I'd probably put names of elements. I'm not testing you on if you know which ones are the alkali metals or alkali earth metals, so I decided to not do that. So in this case it's C, because group 1, this first group here, are the alkali metals. And we have to remember that the atomic radius gets smaller as the atomic number gets higher. So we want to find the one with the lowest atomic number, therefore has the greatest atomic radius. Number 6. So which grouping of circles, when considered in order from top to bottom, represents lithium, sodium, potassium, rubidium? So I'm going to drag this table down here with me. And so if we are looking at these guys here in group 1, we have to remember that when you're going down a group, we're considering the number of principal energy levels. So each element as you go down gains a principal energy level, therefore gains a layer. And every time you add a layer, it gets bigger. So that's how we get A. Number 7, elements that readily gain electrons tend to have. So readily gain means they want them. So remember, high electronegativity means that they really want electrons. And having a high ionization energy means that they don't want to give up electrons. So A is the correct choice. And so this one says, based on table S, which element has the weakest attraction for electrons in a chemical bond? So this is asking which one has the weakest electronegativity. In our case, if we look at the elements that it's talking about, I will bring this table back down. We are looking at these guys here. Oh, that green is not going to be a great color. I'll use black here. So we are looking at these elements, and what we have to remember is that electronegativity trends up. Therefore, polonium is going to have the weakest want for electrons in a chemical bond. Okay, on to the next page. So the diatomic element with a high first ionization energy, what would it most likely be? So again, if we pull up this table, if we remember sorry, I want to make sure you guys are able to read the question. If we remember that ionization energy trends up and over, where do the nonmetals live? They are over in this region. This means that nonmetals are going to have a high first ionization energy. So we're looking now at our nonmetals. Then, if we have to think about the trend of electronegativity, that trends the exact same way. So that's how we get A. This. Which trends are observed on the elements period 3 on the periodic table are considered in order of increasing atomic number? So we are looking at these guys here. And so what do we see when we increase the atomic number or go to the right? Well, the atomic radius is going to decrease. So that's how we know it's not C or D. And then we also have to remember that the trend for ionization energy is that it's going to increase. So that's how we get A. Sorry, I have to keep moving this table around. Okay, so which one of the following group 15 elements has the greatest metallic character? All metallic character means is it acts like a metal. What do metals like to do? They like to lose electrons. So what it's asking is which of the elements wants to lose electrons the most? Remembering that ionization energy is the measurement of that. So things with a low ionization energy are okay giving up electrons. So here we're looking at ionization energy trends. And so if we think about group 15, well, here we also have a group full of nonmetals and metalloids and a metal. Bismuth is the only metal, so that kind of gives it away. But if we were in, let's say, group 2, and looking at group 2, the one closest to francium is going to have the most metallic character. And this is kind of a rule of thumb when you come to the test. If it says most metallic character, which element's closest to francium? As francium has the lowest ionization energy. And if it talks about the most non-metallic character, what's the closest to fluorine? Because remember, we don't consider the noble gases because they're non-reactive. Okay, 12. What are two properties of most nonmetals? Well, if the nonmetals live in the upper right corner, that means they're going to have high ionization energy, and that means C and D are gone. And then you should know that metals are good at conductivity and conducting, so we go A. What is a property of most metals? Metals like to lose electrons, so we know they can't gain. And we know that they are good conductors, so we get rid of C and D, which leaves us with B. When an atom loses one or more electrons, this atom becomes, and so when we're losing electrons, we're losing a negative charge, so it can't be C or D. And then you have to remember the rules. When you lose an electron, the radius gets smaller. And so that leaves us with A. An atom in the ground state has stable valence electron configuration. This right here means that we are in the rightmost group, looking for our stable octet. And so in that case, neon is the only noble gas. 16. Don't worry about 16. I'm not going to ask you a question like that. Okay. 17. An element that's malleable and a good conductor of heat and electricity could have an atomic number of, so we pull that periodic table back. And so if we are looking at it, we find these elements. So we're looking at 16 is sulfur, 18 is argon, 29 is copper, and then 35 is bromine. So malleable and a good conductor of heat and electricity. We're looking for a metal. So copper or 29 is the only metal. We're not going to worry about 18. Pretty much all 18 is wanted you to recognize is that transition metals tend to have colored solutions, but we didn't really discuss that. Okay, which element is a gas at STP? So you'd have to remember the coloring on the periodic table on the front of the classroom. Remember that all the ones that are black are solids at STP, the ones that are blue are liquids, and the ones that are red are gases. So if we look, xenon is the only one that's a gas. Then at STP, or standard temperature pressure, which lists the elements that contain a solid, liquid, and a gas. So what I would do right away is we only have two liquids, bromine and mercury. So I would make sure that at least the combination has one of those in it. So can't be this guy or this guy. Then I would make sure, okay, so we have our liquid. Now I'd find gas. Which ones are gases? Boron's a solid, and so is barium. So that leaves us with A. Which element in period 3 exists as diatomic? So this is recognizing where the diatomic molecules live, which is over here in our fancy little 7. And then remember hydrogen. And so if we look across period 3, that brings us to chlorine. All right, base your answers to questions 22 through 24 from the following passage. I'm going to bring this guy down here. Okay, and erase that. 3 elements are represented by letters Q, R, and T. The 3 elements have the same number of valence electrons. Right there, that tells me they're in the same group. So I'm going to have some sort of element lineup as such. Then it tells me element Q has electrons in 4 principal energy levels. So wherever N is equal to 4 or period 4 is going to be Q. Then it says element R has 17 electrons when it's neutral. We need to remember that 17 electrons means it has 17 protons if it's neutral. So if we find the atomic number 17, that's chlorine. So we know that R is equal to chlorine. And then element T has the smallest atomic radius. So if we know that chlorine, we have chlorine, and Q has a principal energy level of 4, T has to be smaller than both of these two. And since chlorine has only N equals 3, that puts R here. Remember, that's chlorine. Then we have Q, which if it's in the same group, that makes Q bromine. And then having the smallest atomic radius would make this fluorine. Oops, but that was T. So I want to ask the actual symbol for T. We've got fluorine, element Q is bromine, and R is chlorine. Okay, and so here are some more kind of puzzles. So I'm a metalloid with 4 valence electrons. What am I? So I would first find the group with 4 valence electrons. Sorry, I just totally zoned out there. So we are finding a metalloid with 4 valence electrons. So here, notice how you have 2 possible choices. Number 26. Oops, sorry, I forgot to put the other choice on here. I have a smaller atomic radius than nitrogen, and I have 6 valence electrons. So for this guy, we are going to know that it is smaller than nitrogen, and nitrogen has 5 valence electrons. That means this group has 6, so this must be oxygen, because remember the trans radius gets bigger this way and this way, so it's got to be oxygen. I'm a period 3 element with the smallest ionization energy. I'm not a noble gas. What element am I? So period 3. And then you have to remember which way ionization energy trends. Ionization energy gets bigger as we go up and over, so it's going to be sodium. Then I'm an alkali metal with the smallest electronegativity. What element am I? And again, I'm not going to ask you specific questions on what is alkali metals, but these are group 1. And so since electronegativity trends up and over, the one with the smallest is going to be francium. Okay, so for this guy, I'm not going to make you look up the electronegativities. So I will make sure to tell you guys that first, but you would just find them from table S. But we have 0.9, 1.3, 1.6, 1.9, 2.2, 2.5, 3.2. Okay, so that was recording the electronegativity. And so on the grid, we're going to make an appropriate scale and call that electronegativity. It's already labeled though. And then we're going to plot the data and connect the points. So what I would do here is I realize that I'm going to go by 2 units. And I'm going to start at 0.6. Oops, that should be 1. Oh my goodness. Okay, so now I'm going to plot my points. So I'm going to find 0.9, 1.3, then 1.6. Okay, so you should get something like that. Now, on the next page, I'm not going to flip off the graph, but I'll read the question. So it says, state the trend in electronegativity from the elements as the atomic number increases. But what we can see is that as we increase the atomic number, our electronegativity increases. And so that's all I'd want you to state. And so then explain in terms of atomic structure, why does the trend exist? And so here I want you guys to talk about how as we get closer to the noble gases and our sublevels start to fill up with electrons, once they get close to 8, and that's for the elements that exist on the right side of that of the periodic table, they want to be full, and they're so close to being full that they don't want to give up any electrons. And then 34 is saying, okay, let's estimate for atomic number 10. And so, oh, okay, I've been staring at this because I knew I did it wrong. Sorry, I hate when I catch myself doing a mistake. This should be here. Okay, so it is asking to figure out for 10. So as if this was 10, where do you think it would be? To me, seems like it'd be somewhere around 0.6, kind of where we started. And so, yeah, somewhere around 0.6, fine. And then using the reference table, what's the electronegativity for atomic number 10? Well, there's not one. And that has to do with because it's a noble gas. So neon, atomic number 10, is a noble gas, and they have a full valence shell. This means that it's not going to go and form bonds and share electrons with other atoms because it doesn't need to. So we don't measure the electronegativity for noble gases. All right, that is the end of this review, and let me know if you have any questions.